So in the previous video we wrote the code for adding a new node to our binary search tree, and now we want to verify if we are doing it right. Okay, so now let's add a few more nodes. So what we'll do is let's try to have few nodes in our binary search tree. So I'll say that let's say I'm first inserting 10. Let me move this up, and now we are not doing hello world anymore. Let me comment it out. So I declare tree a node, then I'm adding this. So now this block of 3 statements will repeat a few times. Okay, so first I inserted value 10, and then let's say I am inserting value 8, and after that I'm inserting value 5. Okay, and then let's say I'm inserting value 20. Okay, so now I'm creating a tree with 1, 2, 3, 4 different keys, right? So the way this tree should look like is 10 is the root, 8 is the left child of 10, 20 is the right child of 10, and then 5 is the left child of 8. That's the way this tree should look like. Okay, so now if we want to see the structure of the tree, we know that we can do traversals of the tree, right? So let's go and quickly write the traversals of the tree. We know how to do various traversals. So if you don't remember, I'll show you our specifications for traversals. Where are they? So there was pre and in order traversal. Open it. Okay, so now you can see our pre-order and in-order traversals, right? So it's pretty easy to write recursively. So let's go and quickly write it in code blocks. So now what I'm going to do is I'm going to go to my binary search tree, and then I'm going to write a public function, a void function that would be the pre-order traversal of the whole tree, and similarly I will have a void function for in order traversal of my tree, and I also have a void function for the post order traversal of my tree. Save this and let's go and implement them. So now I have void bst1s. First let's say I'm doing pre-order traversal. Okay, so pre-order traversal will not take any argument. We are saying that we want to do traversal by default from the root of the whole tree. Let's say that's the way we have set this up right now. Okay, so now what we'll do, we'll say that first go and check if so now on this we have to do the recursive operation, right? So if you remember the way we had defined pre-order traversal, it was a recursive operation, and it was based on which node you start with. So what we'll do in our code blocks is we'll write a separate function called pre-order inside the tree. Okay, so I'll say that I'll just call pre-order in tree and starting with the root node. Okay, and this is going to be my private function. So I'll say that there is void pre-order in tree, and this should require bring tree node pointer. Okay, I'm doing this because otherwise the external code that calls the pre-order traversal, it will need access to the address of the root, which I don't want to give to the external code. So external code should be only able to say that, oh, perform the pre-order traversal of the tree, and inside that I'm saying that, okay, let's do the pre-order traversal of this tree starting from the root node. Okay, so now I have to go and implement this void function of my BST1. I'm calling it pre-order entry, and it requires one argument from where you want to start. So I'll call it bin tree pointer and node pointer, and now we have to check if this node from where I'm supposed to start my pre-order traversal, if this node ptr is equal to null pointer. In that case, there is nothing to do. I'll simply return. Otherwise, what you do in pre-order traversal, you first perform the traversal specific action. Okay, and here in this case, let's say we are just going to print the contents of the node. So I'll simply say cout, and I'll say, oh, pre-order traversal, and node data is, and say node pointer get data. Okay, and that's the end of line. Okay, so once I do that, then I have to do the pre-order traversal of left, right? So I'll do pre-order in tree for the node pointer get left child, and then pre-order in tree and node pointer I'll go for get right child. Okay, so that's the way it will work. That's my pre-order traversal, and now similarly I can define my in-order traversal, right? So let's go and copy this and use this up. For instead of now pre, I will have the in-order traversal. Instead of pre-order entry, I will say that in-order entry, and similarly I will have the post-order traversal. So let's have the post-order traversal function, and I'll say that post-order entry. Okay. And let's go and add these functions, right? So just like I have private function for pre-order traversal, let's have a private function for in-order traversal and a private function for post-order traversal inside the tree. Okay, so we have three public functions available for the client code to do the traversal of the whole tree, and then we have inside three private functions to do traversal from any node of the tree. Okay, and now let's go and implement these remaining two functions, and they are pretty easy if you have done the pre-order already done. So now I'm copying this, pasting this, and instead of pre, I'm naming it now in order entry. And now the only change I have to do is the way in order traversal works is first you do left, then the node, and then the right. Okay, and then I'll change the cout. I'll call it as in order traversal, and then instead of pre I have to do in order tree, and instead of pre I have to do in order entry. Okay, so that's my in order traversal done, and I'll have similarly my post order traversal. So for BST I have to go and do post order entry, and now the change is in post order is that you first do left, then you do right, and then you do the node. Okay, so now I'll say that I'm not doing in order, but I'm doing post order traversal. And now instead of in order, I will do the post order entry, and here also the post order entry. Okay, so those are my 3 traversals done. And let's go back to our main file where we have done insertion, and now let's just do the in order traversal. So I'll say that tree.in order traversal. I'll also do tree dot pre-order traversal. Okay, so there is pre-order traversal. I'll also do tree dot post order traversal. Okay, so I'm going to print 3 traversals of the tree and check how my tree looks like. So let's first compile and see if this compiles. No, there are many errors, so let's see what are those errors. So there are 3 equal to here, so I have to delete the last one. Fine. And then there is no matching function found for pre-order entry, so I have to go and check what did I do here. It takes binary tree node pointer, right? So so I have to do, this is a function call, this is not directly a value. Okay, so this problem would be everywhere now. To convert this to function calls. Okay, so hopefully that should remove most of the problems. Oh, and I did not remove the 3 equal to signs. Yes. And now let's see if it compiles well. It finally compiles well. So now let's go to our command prompt and check what happens. Okay, so let's go to command prompt, and now I'm going to run my binary search tree. Okay, so look at the in order traversal of our tree. It is 5, 8, 10, 20, which means that these are the numbers in sorted order. And if you remember, if we have built our binary search tree the right way, then we should get the numbers in the increasing order. So we are getting them 5, 8, 10, 20 in the increasing order. Okay, but that's not enough to decide the structure of the tree. We need one more traversal. So let's look at the pre-order traversal. So in pre-order traversal, the first node is 10. It means that 10 is the root of the tree. Fine. So if 10 is the root of the tree, from in-order traversal we know that everything that comes before 10 in the in-order traversal is to the left of the tree. So 5 and 8 are to the left. So out of 5 and 8, who comes first in the pre-order traversal? Okay, so in pre-order traversal 8 comes before 5, which means that 8 is the parent of 5 and 8 is child of 10, and then 20 is child of 10 because it comes after 10 in the pre-order traversal. So we have got the structure correct, and we have also got our traversals done. Okay.